Oh, sweet. Okay, so it looks like everybody made it in from breakfast. So welcome to BGP Made Easy. My name's John. And feel free throughout this presentation, if you have questions about something, step up to a microphone, ask the question. I'll try to fit you in. I do this presentation a lot at NANOG on the road. It's usually a hair shorter than this, so there's plenty of time in this slot for questions to be asked and answered. I very much encourage that. That's one of my favorite things about NANOG is that it's a learning experience, and if you have questions, you should ask. So a lot of us run BGP, where you use it to multi-home on the internet, but what is it? Well, if you're at NANOG, I'd very much be remiss if I didn't give you the snarky answer and tell you to read RFC 4271, because the short answer is always the correct one, especially if you're at the microphone in NANOG. So this is one of the things that I like to tell people to do. But really, what is this? Exterior Gateway Protocol, and it's the only one we use. It's used on the public internet, and it's used for inter-autonomous system routing between autonomous systems. An autonomous system is a discrete network. What does it do? It signals the path to every destination on the internet, in the case of using the internet for BGP, or BGP for the internet. Most major service providers don't contain a default. If they do contain a default, it's towards null zero. They drop it. That's very common. The default gets very nebulous when you have a lot of egresses for your network. So because of that, every router on a major service provider typically knows where every internet destination is. And on a big provider, they often have a very complete view of their internal routes too, not just the global table. And that's required to make a routing decision that's intelligent and not carry stuff randomly across the country. BGP learns multiple paths. And this learning of multiple paths is complete in that it learns lots of them, but it only retransmits its best path. So that's one of the things that people have to think about when you're using BGP. Is a given router may see 6 or 8 paths to something or even more, but it only redistributes its best one. There are some ways around that, like BGP add path, things like that, but they're not in wide use on the internet. So typically a given router has one path that it likes towards the destination. That could be over, if it's internal, it could be towards a loopback of a far-end address that has multiple paths between the two, but often it means that all the traffic towards a given destination is going one way. Why would you run BGP? Well, there's a lot of obvious reasons. Multi-homing and provider redundancy is probably the most common. We're seeing it pretty often these days too with corporations and IPVPNs so that they can control their own routing for private networks. That's a quite common use case these days. While that's not the global internet table, it's still a table that needs to be managed, and you don't want to import or export the wrong routes because you could break your other locations, that sort of thing. Why else do you do it? Well, equipment and port redundancy. That's also a common reason. As internet access has become more and more important, people don't want to have one piece of equipment be their sole point of failure, or one port or one circuit be their point of failure for their access to the internet. And BGP is how you do that with a third party. You can't run OSPF towards a third party because it's not secure for anybody who's used like an IGP like OSPF or ISIS. You can't filter the routes going into it or out of it very easily. So it's not really suitable for use between networks that aren't managed by the same group. Well, the third use case is really peering. This is typically larger ASs, but with the advent of lots of internet exchanges around the world, a lot of small ISPs and enterprises are actually participating in peering directly. That most commonly comes in the form of a IX port, and probably remember the discussion from yesterday morning if you were in the opening session about IXs. IXs range from large to small, but everybody on them speaks BGP. And whether you've joined AM6 with a 8 by 10 gig port, or you've joined a little ISP in like Denver or something with a 1 gig port, those all take fundamentally the same routing policy requirements. You need to run BGP, you need to make agreements with your neighbors, with the other people on the IX, and configure those neighbor sessions. The fourth reason people really run this is connectivity quality. A lot of us these days are looking for better and better quality connectivity to the internet. This might mean most commonly like a cloud service or something like that. Say you're an enterprise and you want to establish a peering session. You might join an IX, establish a peering session just because a couple of your cloud providers are there and you want to make that traffic go directly. Or you might speak to multiple providers for quality reasons. One provider has a bad route to a destination you commonly go to. Get another provider, you both get redundancy and you can manipulate which one is used. The last one that I actually just recently added to this slide that I think is really important now with the advent of ever larger DDoS attacks is that you can do remote triggered black holing with most providers now. And That's where you announce a specific route, like a /32 single IP in v4, to the provider, and they drop traffic destined for that prefix. That's a really important feature if you're under attack and it gets too big for your circuits. There's obviously third-party mitigation you can engage if you need to stay online, but sometimes what's being attacked isn't actually a particularly important device, and you want to keep all your other services up. So remote triggered black hole is something that's good to have in your toolkit of options. Well, how does BGP work? I think somebody before we came in today was asking, are you going to talk about what is an autonomous system? The answer is yes, because I think what an autonomous system is not always clear to people. BGP divides networks into autonomous systems, and I'll get to what exactly that is here in a second, but that is a logical way of thinking of either one router or a group of networks, or a group of routers. What does it do? It exchanges routing information to build a global table that forms the internet. It exchanges the routes you advertise and vice versa. And most importantly, for an edge of one's own infrastructure, it allows application of policy. And this is really the most important aspect. Like an IGP doesn't allow policy to be implemented. It lets you implement metrics, but it really doesn't implement policy. And policy is very important for us in the ISP world because it makes the network reflect what our business decisions are. And I think this is the part where we alluded to it a little bit yesterday in the opening, where business and engineering kind of mix. You got to make your engineering reflect your business practices. But before we get to that, an autonomous system is typically a single network, and it could be one router, it could be hundreds or thousands of routers. But more importantly, it's controlled by a single administrative domain. That's really where this definition comes in. It's all connected together in one infrastructure, and it's one administrative domain. That could be lots of people, but they're all working to the same policy. And you see this globally. You have a tier 1, it's all one AS, it's all one NOC, it's all one engineering team. Those decisions they make are global. They're not unique to like the Seattle POP, because the network across the entire footprint operates the same way. And that leads into a common routing policy. The common routing policy means that they all behave the same way. Their interconnections with other providers behave the same way in every city. And those are identified by an ASN. And that's a globally unique number assigned out just the same way IP addresses are through the hierarchy of RARs from ANA. And that's very important that those are unique because people tie your routing information to them. Although just like IP addresses, you gotta remember there's nothing protecting somebody from using your ASN. That's totally possible at the moment because people don't do RPKI. That's a different presentation, but very, very important to note that this is just like the rest of routing, entirely honor-based. How do you exchange routes in BGP? Well, exchanging routes is done by peering. Peering has multiple definitions and does not mean necessarily free. And this is probably one of my biggest pet peeves in routing linguistics here, is that peering is both used to describe settlement-free interconnection and a BGP peer, which are not the same thing. A BGP peer means that you established a routing adjacency with somebody. It can be for money, it can be for free, it could be over an IX, over a dedicated circuit, it could be over any number of media. But that does not necessarily mean it's free. And that's an important distinction throughout this talk because I think it's confusing that we use the same term. Unlike an IGP, neighbors are set up on both sides. Policy is applied and executed. And this is really important. It's an affirmative neighbor setup. There's no neighbor discovery in BGP. And the reason for that is you don't want neighbors to be created dynamically. You want to be able to create them on a one-off basis. Think if you're an IX. It may seem convenient that you could plug into the IX and peer with everybody magically, but you actually don't want that if you're a big network. You want to understand who you're connecting with, when you're turning it up, what capacity implications that has, and what performance implications that has. So the only exception to that would be, of course, route servers, but route servers typically tell you what you're doing, and they're optional to join at most IXs. So that's the static configuration, and that's what makes BGP unique, and that's really what defines an external gateway, an EGP, and an external gateway protocol, because you need to have those statically confined. Okay, so policy. What is the policy? There's operational policy, I'd put this in the category of only accepting certain routes. You only accept routes you should be getting from somebody. And this really applies to customers and peers, but a lot of people don't actually apply route filtering to their peers. They trust them, and if they don't trust them, they just don't peer with them. Increasingly, it's probably a good idea to put some sort of filtering on your peers if you can, but generally, given the number of routes involved, that means you're going to have to do it in an automated fashion. And that would be generating prefix lists based on programmatic ways of doing it, like a routing registry and generating the prefix list you should see from a peer that way. It also lets you match on communities or set communities, and this is most commonly used for things like remote black holing, or if you look at like the transit guides for most major tier ones, they'll have options to like prepend once, twice, 3 times, do an announce to a specific peer of theirs, or other types of policy you might want. If you have 2 or 3 upstreams and you want one of the other tier ones to return traffic a specific way, you can generally influence that using communities. That's specifying this operational policy. And this is one of the real features of BGP. Really, that takes a second seat to business policy. And I hate to say that as an engineer, but it's really true. We are in the business to either make money, or if we're a nonprofit, we're trying to be as efficient as possible. We don't want to take routes that we don't get paid for or otherwise compensated for across our networks. Nobody here is in the business of taking something from somebody, carrying it across the country, and handing it to somebody else for free. We'd love to think we are sometimes, but that's definitely not the case. The typical problem would be if you're a small ISP, you get global table from transit. And you might have 2 transits. You don't want to re-announce anything you get from one transit to the other, but you will announce your customers to both. Well, that gets really tricky if you use sort of the basic knobs on BGP, which are AS path filtering, prefix lists, and other things like that at egress. That's probably, in at least my operational experience, and I would wager this is mirrored by many people who've worked at bigger providers, it's the most common problem we see with our small customers speaking BGP, is they're filtering using one of these methods that doesn't really scale to have any downstreams, and then they add one. And when they add that first downstream, you find route leaks, or when that downstream customer of theirs cancels, you notice that you're getting a route from your customer that's via their other transit from their former customer, because it was all filtered with prefix lists. And that obviously is bad business policy. You don't want to pay one transit and then send data from your other transit out 2 ports you pay. The other really important piece of this is, route leaks. Route leaks are real bad. There's been many instances of this. If you search in the NANOG archives, the mailing list, you'll find large and small ones for years and years and years. It's been a feature of the internet as long as we've been running BGP. Basically from like the AS7007 incident a long time ago that basically broke the entire internet to more recent ones like Global Crossing accepting lots of routes from PCCW, which you guys might remember. That makes outages for most likely makes an outage for you as the entire internet or a big portion of it tries to route to another big portion of the internet via your network. You can almost guarantee that you're not big enough to take that traffic load, nor is anybody near you. That makes outages in both cases. It overruns all your links with traffic you're not getting paid for. If it doesn't fill your circuits, you're wasting a whole bunch of money. That's not something you want to do. And the other problem is that you're black holing stuff that the rest of NANOG shames you for. And God forbid you're on the NANOG list and everybody knows who you are, and then your AS does that. Because you will get a very large amount of context. And I don't thankfully speak from experience on this, but I have watched it happen. NANOG is not quiet when somebody makes a mistake, as you likely have guessed, just even if you're new. What types of peering relationships do you want to enforce? I mean, this is really what it comes down to from a business standpoint. And typically you have 3. Most networks have transit. And I'm excluding tier 1s because I'm assuming you're probably already got your BGP well in line if you're tier 1. But if you're not tier 1, you have transit, you might have peering, and you probably have customers. Well, those have 3 very different business implications. The first one, transit, costs you money. I don't think I'm just speaking for myself when I feel like transit's the last resort. If I have a route that either is free or is a customer route, i.e. they pay me, I'd way rather send traffic to those routes. So typically you want your network policy to mirror your business policy. And I like to order it in hierarchy of where the money flows. Transit being I pay them, therefore it's the lowest priority from my side. Like for this particular presentation, I use what we use in our network for local preferences. And so in this case, it would be 50, 95, and 110. Local preferences are totally arbitrary. Higher is a higher preference, means it's picked first. It overrides AS path length, which is an important detail if you're talking to people about why their route was preferred. But I don't care what the path length is. If I get the route for free, I'm going to take the free one over the paid one. And that's a very common policy of virtually all networks. Tier 1s do this too. They take customers over peers in virtually all cases. Often you can influence which one of these tiers you get with communities. If you really want to use a transit as a backup, often you can set your routes to be, typically they'd say something like lowest possible or something like that. And in a lot of networks, that's setting it below their peering and below their transit, so that unless they don't see the route from anywhere else, they'll never use the port, and that's a backup only. So sometimes you see it as last resort or backup only preference level. And that's pretty commonly used for people that want to have, say a smaller circuit for backup, but they want it to be there and they want it to take over, but not have any traffic the rest of the time. Well, and I'll warn you, this presentation is rather Cisco-centric. A lot of this can be translated to Juniper, but it takes a little bit of work because the syntax is basically completely different than iOS. I do show some iOS XR examples in here as well. As we keep adding more platforms to the global internet, you have to kind of translate this for each platform because all of them have slightly different ways of implementing what was route maps or route policies on iOS XR. And I think that's an important caveat here. But a little bit of Googling can help you figure out how to do it. You have to have a hair bit of programming understanding, but it's not complicated. It's just if-then statements, so it's pretty easy. In iOS, prefix lists can be applied directly to BGP peer configurations. I do recommend this for customer-facing ports because iOS is not a default deny platform. It's a default allow platform. So typically, my bet is always to put the prefix lists in multiple spots on your configuration so that when the NOC tech removes one of the lines inadvertently, you can't accept a full table from a customer and re-announce it. That thankfully is going away as people deprecate iOS from their core infrastructure, and Junos was smart from day one, and iOS XR finally got a clue about deny by default. If there's no policy, it doesn't do anything, as opposed to if there's no policy, it does all kinds of bad things. Which the subtle laugh you get from people are people who've experienced that problem, which, oh my God, the network blew up because this line of config didn't exist, as opposed to nothing happened because this line didn't exist, which is a very drastic change. On iOS, you'd use route maps. They can match all kinds of stuff. Most importantly, they can match communities and by way of community lists. And that is really important because that allows you to move your filtering around. iOS XR replaces all this with route policies. I've always said that the best way across a network, and this is typical of every major network in the world does this, is to filter with communities. And that's to filter all of your egress announcements with communities. You take and you apply when you get a route, you classify it, you apply a community, which is just a tag. It lets you then explain, to your routers basically where you got the route from and what they should do with it, even if it's the same route. So a classic example of this would be, actually I had a customer email about it the other day. They're like, well, my other upstream uses you and peers with you, but if I don't have transit for them, I don't want you to re-announce the route you get from them via peering, and not on the transit port. And I'm like, that's the default behavior, and it took a little while explaining that that's actually implemented on a per session basis, because a peering session, a settlement-free peering session, will never get re-announced to transit because it doesn't have the right tags on it, whereas a customer session would get re-announced to transit and peering because it has the right tags on it, and a higher local preference. But that's a great example of where this kind of policy gets applied. Filtering only ingress works great for both single router ASNs and multi-thousands of router ASNs. This means like you still can prefix list your customers, and you should, and I would encourage everybody to prefix filter their customers and max prefix limit them too so that they don't deaggregate for recreational purposes, which seems to happen a lot on the internet these days. You can filter at that customer or at the customer edge. You're not going to update it if they want to add a prefix. They only have to add one prefix list. Then anything you get via that session, you tag with your communities that says to your network, hey, this is a customer. I want to announce this to transit. I want to announce this to peers. You have to design the policy in such a way where you don't do things like just announce to transit, not to peers, because at least if in our case, we would not want a customer announcing to us that tells us not to also announce to our peers or our customers if they're announcing to our transit, because you can get some very creative ways of customers black holing themselves, especially if they do stuff like do not announce to your customers and you have single home customers that don't have a default. That gets real fun. So you have to craft the policy in a sane way, but you'll notice that if you look at any of the major networks in the world, their policy is quite similar. The numbers they use are different, but the policy itself is quite similar. The biggest advantage of this, though, is it really lets you scale. You could start at one router and you could keep adding more. You don't have to change the configuration. You might add more communities over time to support, but the beauty of communities is you can have multiple. So you can keep your old ones even if you want to change them out, leave your old ones on, add some new ones, rewrite your policy, change your ingress, remove your old communities. It's totally safe. You can do it as long as you're not deleting your entire config in the process on iOS. You can do that in real time, and it can be done even during the day if you plan it well. In any case, the other side benefit of this is the egress policy facing your peers and transits can be set up to deny by default. And if you didn't already get it from this talk, one of my favorite things is a deny by default policy. I think all networks should, if they don't know what to do with a route, they should definitely not send it anywhere. That is the preferred outcome. And I think that's the way most transits are now working. At least in our infrastructure, what we would do is if we don't have a tag on a route, it literally goes nowhere. It doesn't go to customers, doesn't go to transits, doesn't go to peers. And that way, when somebody turns something up that wasn't intentional or whatever, because that in theory shouldn't happen on a well-managed network, but still somehow does sometimes, those routes then do not escape our infrastructure and do not cause havoc on the internet. Hopefully they're not duplicative of something that we needed internally, but more importantly, they don't make it out. It also does another thing that's really cool inherent in that is when you speak BGP with a customer and you want to send them a full table, you can send them a full table that does not include your internal routes. And this is another thing that we see very commonly with small providers, is that if you take and look at a full feed that they send you, it typically includes more specifics out of their own routes. And that's because they're doing a prefix match and sending everything out that matches a specific set of prefixes, instead of saying, hey, we're only sending our aggregates because we're matching them with communities of the same stuff we send to our upstreams. And for larger networks, those internal routes can be quite a large number of routes, and you don't really want them in a customer's table, because if they accidentally releak them to a transit, the more specifics will take over, which is very bad when that happens. Yeah, because customers a lot of times are peering BGP now with things like firewalls. If a route leak happens on a firewall, that's quite bad for whoever's route was being leaked, because almost certainly it's going to suck the traffic in, drop it, and not send it out the other transit port. So it's even worse than the saturation or double pane example that actually black holes the traffic. In any case, what else can they do? Communities can do all kinds of stuff. At least in our infrastructure, we use them for remote trigger black hole. We indicate location we got the route from. Internal routes are indicated by metro region, all kinds of cool stuff. This really helps as you scale. If you're a larger provider and you're working with CDNs, often they want data on where did this route get originated from? Where is the customer that's in this IP block? Well, that's a pretty important thing to give them, because it results in direct customer experience. And what we're all here for is to have people keep paying their internet bills or paying for their hosted services or whatever. If we didn't have that, none of us would really have jobs. So performance is king. And it's also a good way to work with these partners so that they know where to send that traffic that's easiest for your infrastructure. If you're talking to a CDN, like in our case, in California and Washington, I don't want them to send me the traffic in California for my Washington customers. I want them to know that that's coming from this POP and should be served off this interconnect port. And you could do that with meds and things, but it's much more positive if they know, like, hey, this originated from, Tukwila, Washington, because that POP has that code, and they can just geographically map that. It also helps their geolocation, which is pretty key for a lot of these providers now. Triggering DDoS mitigation. This is probably the newest one that's really come up, is that the DDoS mitigation systems now do diversion routes. And those routes, I don't know how many of you are familiar with how most of the mitigation systems work, but typically they inject a route that could be a /32 or it could be whatever's under attack into your BGP table internally, and they pull that traffic instead of towards the customer, you pull it towards the scrubbing boxes to scrub that. And you may do that at lots of locations in your network. Well, you still need to route that traffic back to the customer eventually, and a popular way to do it is to then inject it back into a VRF that doesn't have that diversion route, and then pop it using MPLS to the destination. And at least that's what we do in our case, and I think that's very common, but it's a way to do it all with BGP. And doing it with BGP makes it so it can scale. This can be done in an automated fashion. Nobody has to configure something. It goes back to normal when it's turned off. And you can do it to many, many destinations at once. There isn't a particular another good way to do that. I've also seen BGP used for a number of other sort of custom applications and communities to watch that. A lot of people use it for any casted services. You might want to tag those with communities so that other particular devices around your network could watch for those services from specific hosts, that kind of thing. In any case, I'm going to switch to some examples here. I'm from 11404, so I use our examples. In this case, this comes back to that policy we were discussing where you don't want to announce to transit and peers but not customers, so you can kind of see how the communities build on each other. There's an announce to customers only community, there's an announce to peers and customers community, and then there's an announce to all three. And that 993 community would be what we would use for transit, for customers that need full transit. That announces to everybody. In reverse, we build what we send to customers by a combination of those three plus the summary communities for all transit and all peers. And I think this is a pretty common way to do it. This eliminates all your internal routes from the feed you would give to customers and makes it a very positive thing. The only real way to break this in a bad way is to have somebody turn up a transit or a peer without a policy on it that you then set up to prefer, but they don't apply a community to it because then you don't re-announce it to anybody. This is probably a best example of where this can go wrong, but also a great example of where you should be fully templating and automating your config. If you're turning out new peers and you're creating new route policies for every peer, you have a problem. Either you're not grouping them or not automating or not templating or all three. That's a policy thing these days. You don't want to be creating custom policy on the fly. It's a area for mistakes, but at least in this way, if you create one that's mistaken, it only breaks you. It doesn't break the rest of the internet. If you want more examples about this, we have an engineering website that literally has no graphics. It's very NANOG appropriate at that URL. Kind of gives you an example of more communities that can be implemented and how they're implemented. I like to show this in action. This is iOS, of course. This is towards a customer. So you can see the ASs in this are real. There are other ASs of our own. Same with the prefixes. I don't use customer ones for this purpose, but you can see where we import prefix list and we assign a route map to it. That route map sets the local preference and the communities appropriately to say it's a transit, and in this case it says it's a customer route, and it says it's, if you looked it up online, you'd say 3010 is the Weston building. So that's a transit customer in Seattle. You can tell that just from the communities. And then you can see what we send out in that full tables output. And I also would really recommend that if you're generating this, use simple names. Use names that make sense to a human. I've always called this the, if you page an engineer drunk at 2 in the morning test, can they figure out what the policy does? And one like full tables out is sufficiently obvious to know what it is. That's our full tables feed to a customer. Okay, cool. And a lot of providers I've seen get really into naming things in what I would regard as a non-human readable way. And I've always been somebody who thinks that's quite dangerous, because when something really goes wrong, humans need to look at the configs. You don't really want that to be your standard mode of operation, but you want that to be possible, and you want it to be intelligible. And I don't get paged very often, a few times a year now, but like when I get paged, it's usually at 3 in the morning, like after I fell into a deep sleep 5 or 10 minutes before. And I don't know about you guys, but those are the times where I'm very thankful for easy naming conventions, because I'm trying to figure something out in a hurry. And I really believe that it helps with the mean time to restore quite significantly. And we've had this debate internally, and I do actually in our internal meetings call it if the engineer is drunk test. Does this work? Because that never happens, right? Nobody's ever been paged while drunk. Or incredibly tired. This is the same exact implementation, but implemented as a route policy. So this is iOS XR. You can see we're setting the local preference, and we're saying the community. There's a community set that sets the communities. So iOS XR is easier to use community sets in. So there's a customer in community set for this router. As opposed to saying them manually on the route policy. I think that's another example of where you can summarize. And for a given router, every customer should have the same community on that router in most cases. So if that's the case, do something simple, call it customer BGP customer in. That's what every customer that's full table that's announced to the global internet gets on that router. Share as much of the config between route policies as possible so that they're simple and people aren't touching the complicated parts of the config, because that's where it always goes south. And we had an incident just the other day where customer called in saying their remote triggered black holing wasn't working. The config was tested in the lab, like it's the config that's on all the routers. That did not stop the on-call engineer from reconfiguring the policy, even though the underlying cause was the customer not sending the right community tag for the black holing. There was no policy problem on our side, but it was the customer not saying the right community. That is the kind of thing you want to avoid people thinking needs to be troubleshooted. You shouldn't have to troubleshoot your default policy. It should be well vetted. And if you have a lab or even a spare router or two, setting that up and testing the various iterations of it, making sure it all works, is great, because then they can be cookie cutter across the whole infrastructure. And cookie cutter is the key to reliability. It also is the key to automation. Even if you don't automate up front, if all your configs look the same, it makes it much easier to automate in the future. This is the same config towards the transit. This is towards XO. This is one of our XO peerings, or transit peers. And you can see we're doing descriptions that match that rule, keep it simple. And then there's a route map going in and out on each. And you can see there's a couple things in here that I like to note. We always ignore meds from transits. I don't want a transit to tell me to haul it across my network to somewhere else to hand it to them. I'm already paying them. They charge the exact same amount wherever I send it. I'm not carrying the traffic across my transport between markets, so I always set meds to 0 that I get from transits, especially peers. I would typically set to 0 unless it was otherwise negotiated. Just depends on the player. And then you can see that lower local preference of 50 being applied. And that lower local preference of 50 is the transit local preference. That says, hey, if nothing else is available, I'll take this. This config can get a little more complicated if you have paths you like and don't like. You can make more iterations of it. And the reason I don't set like 50, 51, 52 for my preference of transit, peers, customers is because I like to have a little bit of ability to raise and lower. Because in the real world, you find that certain paths over certain transits or peers are bad, and you don't want to take them. And so that lets you duplicate this route policy and apply an AS path match to it, and match a path you either like or don't like. And so typically in our infrastructure, paths I like, I actually set to like 55. Paths I don't like to 50. Paths that basically don't work to 49. So never use this path unless there are no other ways to that destination available. And I always do it with local preference, and I think that's something that's very important to get people in the mindset of, is don't ever block something what you're getting from a full table transit, just lower the preference enough where you don't care. Because if you block it, that's asking for you to create black holes at some point. Somebody will change an upstream at some point. You'll go through a few upstreams, and pretty soon your only path to some random network that will drive tech support calls is actually blocked. And people are like, why can't I get to this website in Romania? I don't know. And you look at it and you're like, somebody blocked the whole destination. So you don't want to do that. You want to just lower the local preference so that, worst case, they're headed towards a route that has a local preference that's the I don't care at all local preference, because it will still work. In this case, you can see the outbound route filtering being applied as well. It's matching just two communities, 993, which is the one that's transit, and then I keep a specific one that says announce only to this one transit, and that's used for specific traffic engineering internally. We have some cases where some of our routes, we just list a couple of transits in that market and don't announce them to our global transits, but we don't allow customers to do that because it gets weird in a hurry when customers try to do it because they don't usually understand where you're connected to which carriers. Some real world examples. You can actually see this if you do a show IPBGP on one of our routers. This is a old 6500 that's actually not there anymore at this site, but it shows it quite well. So it was a Portland router. You could look at this /20 and you could see that it was coming in from the loopback of a Seattle router, and the reason we're seeing the loopback is this is all next hop self infrastructure for BGP, so all the iBGP sessions are built between loopbacks. That's the part I don't really cover in this, is how to build your iBGP infrastructure, but that is its own mess in itself, and I'll take lots of questions on that, but depending on your topology, building iBGP infrastructure gets really hard because a full mesh typically isn't possible if you have tons and tons of routers. But route reflectors have to be designed very carefully to not create new single points of failure. And I've seen a lot of cases where people have gone to route reflectors but not understood that, okay, I have 5 sites, and these 3 sites on this side are all route reflector clients of 2 routers in this one POP. What happens if that POP goes dark? Does all your connectivity really go through it? And often the answer to that is actually no, but you lose all your routes. So if your connectivity is up with no routes, that's the worst possible situation. So iBGP configs actually take a little while to design how to do that in a way that scales well. Big networks typically would do full mesh between like major sites and then route reflectors from those sites downwards. But if you're regional, it gets much more complicated because you got to understand the individual fiber routes around that. Here, though, you can see that this is being announced in bold to transit, and it's a customer in Seattle, just like we saw on the import from the prior slide, where the prefix was imported into BGP via the route map, and you can see that it's coming from Seattle. And in this case, Seattle actually means the Weston building has its own code. This is the same thing, but a black hole, and I think I use the same. No, I use the other router, but you can see that router is now iOS XR, that pair, and this would be a great demonstration of showing something that's been black holed. The only caveat with creating your own black holing infrastructure across the network is that you have to rewrite your next hops, and that gets a little bit tricky because if you actually want a distributed black hole, you have to go around on all your routers, and when you set this community, they have to recognize it and rewrite the next hop to be like a null interface. And in our case, what we do is we actually use the example subnet, which you'll see here. We use 192.0.2.0/32 on every router in the infrastructure is routed towards null 0. That allows you, if you set that as the next hop, which is done using this community, the 11.404.666 community, that nulls them all towards 0. And having it actually be distributed is particularly important, given the volume of DDoSes that people see now. You don't want one router to be syncing that traffic. You want your whole infrastructure at every edge to be syncing in. But what's cool is if you implement with the community, you could do the same stuff we did before and rematch that policy and re-announce it to your transits and rewrite it to their black hole community. And this is like my personal favorite is that, yes, we might be black holing it, but I also want every transit of mine that supports remote triggered black hole to black hole it themselves and never even deliver it to me if we're black holing it. And you can do that because you're tagging it with communities. You're not just statically routing it towards null 0. You can put that as part of your egress policy. So I'm intentionally finishing a hair early here because we got filled up with a whole bunch of people with it looked like they had questions initially. And so I'd love to open this up for people to ask questions, because we'll have about 30 minutes to ask questions. Yes, Nikos.
Do you really get more specific routes from customers?
I don't, but because I filter them. But a lot of customers actually, I'd say probably 70% of our BGP speaking customers announce their global aggregates and then a whole ton of /24s from their global aggregates. This has become a huge problem across the internet these days. And it just have to look at any of the routing reports, and the internet is like, what, 75% /24s now? And that's really just not healthy, because most of those were not, RAR allocated /24s. Jump in.
Sandy Murphy, Parsons. You said over and over again, prefix filter your customers. Can you discuss filtering on peering relationships?
Yeah. So
I like to look at hijacks and then look at who passed that bogus route around.
Yeah, and that's a really good question. So prefix filtering on peers has proved to be incredibly difficult. And there's basically two reasons that are not necessarily directly related, but I think administratively they're related. One, there's, at least in North America, and unfortunately you really need it for the whole world, there isn't a good routing registry that has useful data. Anybody who's been around for a while, if you actually pulled a filter based on like RADB AS set data, would have like 10 times the number of prefixes in that AS set that are actually being announced, if not 20 or 30 times. I know, because nobody ever removes the data. It's just garbage. People don't get removed from AS sets. People don't remove route statements from RADB or any of the other RARs. You go in there and, like, I've got ARIN prefixes that we got allocated to us by ARIN 5 or 6 years ago that still had RADB entries from the mid-90s in there that were from ISPs that went bankrupt in '99 that then went through the whole timeout for all their IPs to go back to ARIN and then went through the cycle for me to get it, and the stuff was still live in the routing registries. So effectively, they're not useful for peering filters. The gold standard solution would be RPKI, right?
Strangely enough, I'm standing at the mic.
But yeah, no, that would be the gold standard, but then you have the exact same problem that instead of there being a whole ton of garbage data, there's just no data. There are a few prefixes that are registered, but as a percentage of the global internet, it's quite small. And so what do you do with all the ones that don't match? Do you set them to a lower local preference? What do you do? The problem with that is, I think I'd be of the mind that if I had verification on it, I'd probably set to my default local preference for the peer anything that matched, and then set all the ones that didn't match lower. It doesn't really solve the prefix hijack problem, because prefix hijacks are typically more specifics. And so that would still take over. Local preference isn't relevant at that point. And I'd love to see us get to a point in the internet where we could actually drop traffic that was towards unregistered prefixes. But I don't know how many people in the room have polled their customer base. I know I haven't, but I can guess what would happen if I did that to our call center. And we'd be finding every small web host in the world that didn't know what either RPKI or a route registry would fall off the internet from our perspective. And I'd have 100,000 of our 500,000 cable subscribers calling our call center at the same time, saying, my internet doesn't work to my favorite website. We'd find out a lot of new favorite websites, I'm sure. But that's kind of the problem I see with it. I think we might get there with RPKI. It's going to be a little like the V6 deployment, unfortunately, I think.
I think it's already going faster than the initial V6 deployment. So one of the problems that I've heard expressed is that you have to kind of like include in your prefix filter everything in the customer cone, not just the customer, but the whole cone, which means you're regenerating your prefix filters all the time. The RPKI has, you express the origin, and it doesn't matter how it gets to you. You can decide the origin. Your examples of prefix filterings would be good places. It's an easy match for valid and invalid and
Yep.
not found. So at some point in the life, I was wondering whether you thought that that ability would make it possible to check on the peering connections, because you don't have the volume problem. I have to recommit a configuration file that's what Jared's figures 400K or something.
Yeah, and that's really the problem with classic prefix lists. The numbers that Jared throws out are, I think, quite accurate because the internet's gotten so big. Even if you put some good summarizing code in, prefix filters just don't work on peers because, frankly, routers are slow and iOS XR is still 32-bit, not 64-bit. So you start putting large, which I don't know how many people actually knew that, but that's the hypervisor for it is 64, but the actual code that the BGP daemon runs is 32. So it's severely limited in the amount of RAM it can address and other features like that. And I don't think Cisco's unique in that particular problem. But I think really more to your point, if we had fast enough CPUs in the routers to do that, or an outboard way to do it to feed the filters to it and not put the infrastructure at risk, I think that would be the way to go. And we're kind of moving that direction. You know, routers are getting faster, and there's outboard solutions for processing the updates, which I think from our standpoint, like at least in my infrastructure, I'm particularly nervous about making my accepting of routes dependent on like a server somewhere. So I'd have to have it set up so where I'd allow by default effectively. Like if I was down internally and couldn't validate, I'd accept. That's easily solvable. But you do have some problems like that you have to work through because you don't want to make your infrastructure more fragile. But if we could do it, that would be great. Like in our infrastructure, thinking about it, just our own customer cone would be a huge amount of work for our support team to make sure they all were validatable. Because we, as their upstream, if we're their sole upstream, I can't not accept their prefixes if they're not validated. And we have about 2,600 routes. You start thinking how to scale that up in terms of your NOC staff and stuff, contacting and walking what in some cases are marginally clueful customers through how to do that. That gets really interesting. The other thing we see a lot that I don't know how it's going to be reflected is people swapping space around, either for DDoS mitigation providers or one provider subleasing some IP space to someone else, because keeping the whois records up to date is proving to be a problem, let alone keeping assigned origin validation up to date. Because my suspicion is that those are kind of two levels of difficulty. You have the whois is a pretty low bar, and the origin validation is a hair higher bar, but not much, right?
Yeah.
But if you find that like company's been bought 3 times and they've given this space to whatever company ended up with those assets, I just went through an issue where we were using a bunch of IP addresses that were 4 years out of date from a merger and acquisition because nobody had realized it, and it had about 50,000 cable modems in it.
Oh.
And so like that would have been a problem if that was validated because, well, A, we wouldn't have been able to announce it, but nor would the other party that acquired part of this bankrupt entity.
So how do they update the whois if the
Painfully.
Aaron doesn't know? Well,
painfully.
Yeah. So once you've got reestablish the relationship with Aaron, it's just a click to do ROAS.
The real trick here is that the whois data is sort of hopelessly out of date in a lot of cases, because that policy of getting up to date with Aaron is difficult on purpose because of people stealing space. But when you're going through an M&A, I mean, I probably put in the last year in the 3 or 4 companies we've bought, like 20 or 30 hours into dealing with Aaron on transferring stuff. And like, I know the reviewers, and they know that I'm not like a spammer trying to steal the IPs. Just providing the documentation that's required by policy is tricky. Well, if you start making that process be required to keep them reachable as you merge the infrastructure, that actually becomes really tricky. And I don't know totally how you do it, because if you buy the whole company, you probably have their old access. But if you buy part of somebody from bankruptcy, or acquisitions are not always as convenient as you bought the whole thing and you now have access to their old contacts, as that of course would work.
Right.
You wouldn't need Aaron to update.
Right. And as we're proceeding into an era when IP addresses actually have some monetary aspect to it, it may be that people start paying a little more attention to whois entries. We can hope.
I can hope. Yeah, I think you're going to see that, and we're going to probably see theft if we haven't already.
Yeah.
I'm sure we've seen theft already that we just don't know about. You know, everybody has, because IP addresses, I don't know what's the going rate now on the marketplaces, you know, 12 or 1,300 bucks for a /24. Well, you know, people are going to be trolling those for what defunct company has what space that I can swipe and nobody will notice. I mean, you know, it's sad because being dishonest actually wouldn't be that hard in those, because you're providing legal documents to Aaron that they have no way of validating. I mean, if you do a transfer, you're sending them your purchase agreement, but do they know that the purchase even happened? Is that even publicly available? Unless they're public companies, probably not. You know, I know we don't publish anything about what entities we acquired or how we acquired them, so just because they came from our lawyers, that doesn't mean they're actually the real docs, right? And this is a sad state of affairs, that the internet's so based on trust that we start seeing that trust evaporate as resources and actors get less honest, basically.
Okay.
Anyway, does that answer?
It was a wonderful answer. Thank you.
Any other questions on this? How many of you guys run BGP for your ISP? Or so, good percentage of the audience. And some of you I know are big networks that I see raising their hands. Any other actual technical questions or implementation questions? Yeah, jump in.
Stanley Botanic.
Yeah.
Can you revisit what you spoke about using communities to mitigate DDoS?
Yeah, so if we pop back to that slide, let's see here. Really, one of the things we do, and I think this is very common, and obviously the vendors that are involved are like, you know, Arbor, Radware, the usual suspects, but they effectively all work the same way, is you have some sort of mitigation cluster that's usually hanging off dedicated ports on one or more of your edged routers in some form. Typically we use not the core, but the edge, because we don't want to carry it into the core. We'd rather dump the junk as quick as possible towards our transit and peering edge. But typically how you would do it is you'd inject into your default table a diversion route that says shoot it towards this box. And it might be a loopback IP that you're injecting, because if you have a lot of scrubbers, you might set the next hop to a loopback, and that loopback might be statically routed towards every scrubber that you have, so that all scrubbers are taking it with one route injection. That would be pretty common, but to get that back into the global table, that traffic back following the normal forwarding domain, you actually create, at least on Cisco, you create a VRF that imports your whole global table except the diversion routes with the next hop, and the clean side of the traffic would go into that VRF, and then those routes from the global table are leaked into it that don't have that. So that VRF doesn't have the more specific that would create a loop, and then it would route the traffic that's in that VRF to the next router destination downstream. And in some cases, you might pop it with MPLS the whole way to avoid a loop in the MPLS.
Is there really any reason to import the whole global table? Would you just import your global table?
You can do that too. Hopefully it's not. You can do, yeah, absolutely. So his question was, do you need to import the whole table? And I've done that mostly because, at least on iOS XR, it doesn't have much of a memory penalty anymore. It used to have a fib problem to do that, but now it doesn't. It actually shares the fib entry, so you can do it safely if you're directly copying your global table into the VRF. Yes, so that's the answer of why I do it that way on XR, because I actually lab tested it and was like, this is cool. It only uses like 20 megs of RAM to do this. Because I was worried about and for those who don't know, at least on most routing platforms, the gating item is the number of routes you can put in the fib. The actual forwarding table, because that's what has to be forwarded in hardware. And a lot of times VRF routes count as a second route, but they've made it so that in this particular case, if they're identical, it can use the same entry, which is particularly important for this. Does that help answer your question a little bit? I don't know what platform you guys use, so that particular answer would be dependent on the platform. No other questions? We're at exactly an hour into this. So I was hoping I'd have like 25 minutes of questions based on the number of people that walked in. Oh, well, I guess we're going to finish a little early then.
So I guess a little bit of a statement, more than a question.
Yeah.
Filtering or exporting to what would, in our case, most likely be commercial customers in distribution. Why not?
It seemed like sort of a mic-less question setup. So in a lot of cases, in ours in particular, we have an internal group that handles DOCSIS, right?
Yep.
WOW, James Ashton, WOW, cable. And we are finally getting them moved over to BGP so that we're doing BGP with the CMTSs and accepting their routes and therefore able to easily tag communities. But prior to this, it had been all static routes and OSPF because that was all the
Sounds
CMTSs were
really
capable.
familiar.
Yeah, no, I'm sure. But it's your export filter to your commercial customers is a lot more complicated when those routes are not in BGP until they get to the edge.
Yeah, and I think my recommendation for that particular config would be if you have to speak OSPF to a device on your network, speak it in another OSPF instance that's and then re-import it into BGP if you possibly can. Like say you have a CMTS and then you have like aggregation routers at that head end or whatever. If you possibly can, put your CMTSs in another OSPF instance so that you're not polluting your main OSPF table. But I come from a cable side too, and I can tell you that like in our infrastructure, that wasn't even possible because the amount of gear that was deployed didn't allow it.
Exactly. That and M&A. And
yeah.
you always end up with networks that you haven't had time to do anything to yet.
Yeah.
So you always end up with those routes somewhere in your IGP because that's just how everybody always did it.
Yeah.
So that's, in the end, at least until we get everything moved over to BGP, which we're in the process of, we're still using actual prefix lists because,
there's no other good way to do it.
Yeah, the internet, all that stuff comes in. All of our upstream and peer routes come in through community, but as far as our internal stuff, we don't really have any way of doing it other than a prefix list at the moment.
And I think at least in our case, the way we handled that was probably the gold-plated approach. It happened to more recently coincide with a CMTS upgrade and a backbone router rebuild, which is a luxury that most people don't get. So we left the old turd going with its OSPF everywhere with everything in the OSPF table, turned up a new infrastructure, connected eBGP between the two, and started rolling CMTSs to BGP one at a time. But because there were no customers on the edge AS, the default would work and you'd not create routing holes by doing it. So you could just basically nab the traffic before it reached the legacy infrastructure by the BGP connected CMTSs. And so we've been rolling in one CMTS at a time. But honestly, that is very hard to do live if you don't also have a big other project for replacing hardware going. In cable land, that happened to coincide with us going to 16 and 32 QAM everywhere for downstream, which is, for those that aren't cable, that means prepping to offer 1 gigabit cable service, which was a big capital initiative on our side, and I think that's likely the same as a lot of people these days are doing big upgrades in their DOCSIS plants to try to offer next generation speeds, but that often means more CMTSs, which made it a little more flexible. But if we hadn't been doing that refresh, I think we would have been trying all kinds of crazy route policies and trying to shrink OSPF domains and import them at specific strategic locations and do it all without creating a new single point of failure, which is the fun part.
Did I hear you recommend redistributing OSPF into BGP?
Only in very specific circumstances. So the question was, this is the trick question because redistribution is typically quite bad. I typically on our internal infrastructure do redistribute connected and statics just so that somebody could put, and I do it without filtering into our internal BGP table. But that also means it never gets reannounced to anybody. That's specifically for our enterprise team going IP route towards a customer circuit that has like a dedicated IP allocation, so that just works without having to contact any of the backbone team. The question that Nikos is bringing up is really one of should you redistribute OSPF into BGP, and the only situation in which I would ever do that is if you have a dedicated OSPF instance for talking to a device that doesn't speak BGP. And so that's reasonably safe. Put some communities on it, have that OSPF instance only be on a couple routers and only be on the devices that don't speak BGP, so that it's a very small contained number of routes. Then that's probably safe. You still need to put some careful guardrails on it, like not importing your default and some other fun things like that. It is very ugly, and it's one of those ways, and actually the place we've come up with that the most often is acquisitions. And we usually use an internal set of communities that we just apply to, hey, this is an internal-only route. It came from something like this. That would be kind of my method of it, and then try to eliminate it as quickly as possible. And I think that comes from, there's sort of two schools that actually we were just talking about, where older networks typically had every device running OSPF, and newer networks typically have the IGP and BGP, and like customer routes are only in BGP, just like peering and transit routes. And that's kind of how we've changed as the number of routes has gone up. And part of that is really a lot of backbones now have many more links in their backbone. So actually controlling OSPF table size or ISIS table size is pretty important for convergence times. And like a big ISP might have 10 or 20,000 customer prefixes. You don't really want those in your OSPF anymore, because you want your OSPF to reconverge and actually come up quickly so that your BGP sessions that rely on that IGP being up and converged can start being brought back up very quickly if a router loses connectivity. Anyway. Oh, yeah. Jump in.
With regards to what you were talking about before about redistributing static and connected into your IBGP, do you have any special sauce from your experience in how to prevent the your transit/30s and your peering blocks from not being redistributed?
So in those ones, it's not necessarily bad to have them redistributed in BGP. So, but classically you would have put them into your IGP, right? But now if you can do next hop self, you don't need them in your IGP, which is the reason for setting next hop self on your IBGP session, so that instead of the peering or transit far in network, you actually get the network that is, the loop back on the router. But there's been a fair number of DOS attacks, and I think this is probably what you're mentioning, this because of the prominent one was towards, I think it was Cloudflare via links. I can't remember exactly who it was, but a lot of traffic ended up destined to the exchange prefix, and people were carrying it. So the IP block that belonged to the exchange was under attack, and that was reachable because people were carrying it in their IGP. And so, so it happened to you too. So I think there's sort of two pieces of policy there that are important. Whether or not you carry it in your IBGP is probably not that important, but what you really need to do is, if you're at one of these IXs, is have proper egress filtering facing the IX. You shouldn't have any traffic destined towards those prefixes except your own BGP sessions. There should be no other traffic destined towards them, and you should only accept traffic from them. And the reason to accept traffic from them is so that trace routes work, right? Because if you accept traffic from the IX prefix, that's the TTL exceeded messages that make a trace route work. But you should never have anything towards the IX prefix. And the same thing goes for all your transits and peers. And I think any of us that have been under pretty large DDoSs probably have noticed that what happens is people like to DDoS everything they see in the trace route. And I don't know how many of you have seen that, but I've seen it multiple times where, like, literally every hop in the trace route, like, you take the destination that's being DDoSed and 8 hops back, every one of those /32s that the customer can see in the trace route is now under DDoS at varying levels. Like in our infrastructure, we solved that by actually allocating all of our backbone subnets out of dedicated prefixes that are filtered at the edge of our network everywhere. And they're only ingress filtered, they're not egress filtered, so the trace routes still work. Customers can't tell they're filtered. The only way they could tell is you can't ping what you see in a trace route, which sometimes breaks things like MTR, but we tell people they shouldn't be running that anyway because it's not a useful. Our official response is that pinging the routers on the destination has no bearing of anything on the end-to-end latency.
Some IXs spend a lot of time policing the redistribution of the IX network internally.
Well, and I think there's a difference between redistributing internally and re-announcing it to customers. So, like, if you looked at, we're a member of the Seattle IX, Nico's a member of the Seattle IX, and like the Seattle IX prefix is in our IGP, but we drop traffic destined towards it, and it's not tagged with a customer announced prefix. So a customer would never see it in their feed from us. It's technically in ours, but there'd be no way for the IX to detect that other than our own looking glass, because we actually drop the traffic. Yeah, but for the IX's portion, it actually doesn't matter which it is. Because as long as you're dropping the traffic, you're doing the right thing. You need to not deliver that traffic to the IX. And that's really the gold standard, is just don't deliver the garbage traffic, because there should be no traffic to an IX. I actually should probably add that to one of these presentations. There's ACLs towards an IX or towards a transit, because it's actually pretty easy, because, I mean, you really have to think about it. All you have to do is redistribute or allow BGP, which is just it's one TCP port. And so that's actually quite easy. You know what port is going to be on span 179. You know that. You can put that in your edge filters. You know what destinations it's going to talk to. So at least in our typical ACLs is that we allow anything to anything on the edge devices that is source and destination of the IX prefix. So the other IX members can ping us and do whatever they need to do directly towards our edge, but nothing internally on either side can pass towards those prefixes, which is kind of a nice solution. Any other questions? No? No other questions. Okay, thank you guys.